A fusion method to build a model for prediction exchange rate from USD to VND. Abstract in this paper, the combination of the Hilbert Huang Transform, fuzzy logic system and an embedding theorem is described to predict the short-term exchange rate from United States dollar to Vietnamese Dong. By using the Hilbert Huang Transform as an adaptive filter, the proposed method decreases the embedding dimension space from 12 original samples to 4 denoising samples. This dimension space provides the number of inputs to the fuzzy rule-based system, which causes the number of rules, the time for training and the inference process to reduce. Experimental results indicated that this method not only reduces complication of the model but also achieves higher accuracy prediction than the direct use of original data. Keywords: embedding dimension space, average mutual information, fuzzy rule-based system, prediction, HHT. Introduction. Forecasting financial time series serves an important role in daily life, especially the exchange rate forecast that helps an importer and exporter to choose the best time to import or export products to obtain the highest profit. Researchers have successfully employed approaches for predicting exchange rates. In one, authors combined kernel regression, KR, and the function link artificial neural network, FLAN, to predict the exchange rate from United States dollar, USD, to British pound, GBP, Indian rupee, INR, and Japanese yen, JPY. KR served a role in filtering, and FLAN was a model for prediction. The authors in 2 use chaos theory and reconstructed state space for predicting the exchange rate between USD and Euro, EUR. Fan 3 uses a hybrid discrete wavelet transform, DWT, and support vector regression, SVR, to predict the exchange rate between Chinese yuan, CNY, and USD. First, this researcher uses DWT to decompose time series data to different time scales and later appropriately chooses a kernel function for SVR and a prediction that corresponds with each time scale. Her synthesis prediction is obtained from different predicted time scale results. The authors in 4 use a local fuzzy reconstruction method to predict the exchange rate between JPY, USD, and Canadian dollar, CAD. The authors in 5 use a successful wavelet transform to filter noise in the exchange rate time series before using it to train and predict the base on the multi-layer feed-forward neural network. Whooping Lu 6 uses a hybrid neuron and fuzzy logic to predict the exchange rate between JPY and USA. In 1998, Dr. Huang proposed a novel method for decomposition nonlinear and non-stationary time series into a set of multi-time scale signals, which are referred to as intrinsic mode function, IMF. This method is successfully applied in many fields, such as an adaptive filter for non-stationary and nonlinear data 7, 8. In this paper, the combination of HHT, fuzzy logic system, average mutual information and an embedding theorem to predict the exchange rate from USD to VND is presented. This method is simple, adaptive, and high accuracy prediction. This paper is organized as follows. In the next section, related studies are presented. Section 3 discusses the principle of the proposed method. Section 4 demonstrates the accuracy prediction of the method by experiment. Section 5 presents the conclusion and future studies. 2 related work. A. Finding the time delay. According to the literature review 11, if we select 2 small time delay t, then 2 data points s, n and jt, and s, n plus, j plus 1, t, will be so close to each other that we cannot distinguish them from each other. Similarly, if we choose so large t, then s, n and jt, and s, n plus, j plus 1, t, are completely independent of each other in a statistical sense. To determine the proper time delay of a time series we can base on average mutual information. Assume we have 2 systems called A and B, and measured values from those systems denoted by AK, BK. The mutual information between AK and BK is specified as equation 1, below. V. Conclusion. We presented the combination of HHT and the algorithm of false nearest neighbor to obtain a minimum embedding dimension space, average mutual information to find the time lag of time series and fuzzy rules-based system to predict the exchange rate between USD and VND. The HHT serves a role in adaptive filters and reconstructed signals without high-frequency oscillation, IMF1, can reduce noise. We use a denoised signal to obtain the time lag, and the embedding dimension space and the training fuzzy logic model. The experiment revealed that the denoised signal can decrease the embedding dimension space, decrease the complexity of the system and achieve higher accuracy prediction than the direct use of the original signal. In the future, we are going to apply more soft computing techniques such as feed-forward neuron networks, FFNN, support vector regression to build the model for prediction exchange rate, compare the accuracy prediction among models to choose the best model for prediction exchange rate between USD and VND. Acknowledgement. This work is supported by the Hanoi University of Industry.